In this video, we want to test the difference between two means, two population means. In this case, we're dealing with vitamin C pills, tablets. And what we want to know is if we have the population of Vitamax pills, that population has a mean regarding the content of vitamin C, and so does the population of Super C pills. Let's call it mu1 and mu2. And we want to explore if there's a difference between those two means. In order to do that, we've taken a sample from each population. In each case, the sample consists of 5 pills that we've measured the vitamin C content of. And then we want to use this data to make a statement about the difference between the two means of the populations. So our null hypothesis is about the difference of the two means, and our hypothesis is that the difference is equal to 0. That's a typical hypothesis. It doesn't have to be 0, but that's my choice in this case. And the alternative hypothesis is that the difference between the two means is not 0. So how can we decide which hypothesis to accept? We have to do a test, of course, and it turns out that the t-test for 2 samples is the one we want. But before we do the test, we have to know whether these two populations have the same variances. Now, we don't know the variances of the populations, but we do have these samples, so we can estimate the variances and test if they're the same. Now, that requires a different test called the f-test. And I'm not going to do that here. I'm doing that in another video. But what the f-test does is it tests the hypothesis if the two variances are the same. As I said, we're not going to do that here, but if we did it, it would turn out that we could believe in that. So it's no question anymore. We can use an f-test to show that the two variances are the same. Of course, we can only show it at some level of significance, but for now we'll just assume that we've shown that these two variances are the same. So that's the working hypothesis for now. And given that the two variances are the same, the test statistic that we use looks like this. Kind of familiar. We take the two sample means and subtract the hypothesis value, which is 0 in our case, and we divide it by the pooled standard deviation times the square root of 1 over n1 plus 1 over n2, where n1 and n2 are the sample sizes. The pooled standard deviation, well, let me show you how to compute the pooled variance. You can find that in the book as well. It's really just a weighted average of the two variances. It looks like this: n1 minus 1 times the variance of the first sample, and n2 minus 1 times s2 squared, so the variance of the second sample here, divided by n1 plus n2 minus 2. And so this is the pooled variance. If we want the pooled standard deviation, then we just take the square root of that. like that. And we have the pooled standard deviation here. And it turns out that this test statistic has a distribution, which is the t distribution. That's why we call it a t0 test statistic. And that t distribution has n1 plus n2 minus 2 degrees of freedom. So now we're going to do the test in Excel. Here we have the data, and the first thing I want to compute is the mean. So you type average in English, in Danish it's middel. Like that, and then the mean of the second sample here. Oh, sorry. Forgot the average keyword here. Like that. And then we need the standard deviation of the first sample. So, and remember, it's the sample standard deviation that we need. And here we want the sample standard deviation of the second sample. Like that. And for completeness sake, I'll punch in the sample sizes. And then we can compute the pooled variance using this formula down here. So that's n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared. And we divide by n1 plus n2 minus 2. So that's the pooled variance, and the pooled standard deviation is then the square root SQRT of the pooled variance. And then we're ready to compute the test statistic. That's, sorry, x1 minus x2 minus 0 divided by then the pooled standard deviation times the square root SQRT, if you're in an English keyboard, of 1 over n1 plus 1 over n2, close the square root, close the denominator. So that gives us a test statistic of minus 7.88. That's quite a large, numerically speaking, a large test statistic. This would this indicates that we're going to reject the null hypothesis. But let's just compute the p-value. It's a two-tailed test, so the p-value is equal to 2 times 1 minus, and then we need the t distribution, t dot dist in an English keyboard. Here it's called t for Danish. And we input the absolute value of the test statistic. And then the number of degrees of freedom, which in this case is n1 plus n2 minus 2. And then we write true, or in Danish cent, because we want the cumulative distribution function. So this gives us a very small p-value, 4.857 times 10 to the minus 5th. So that's a very small p-value. So at a significance level of 5%, we can surely reject the null hypothesis. So the conclusion is that we've shown that the means of these two populations here differ by a significant amount, and by significant I mean at level 5%.